The latest report by the Intergovernmental Panel on Climate Change has signaled code red for humanity. Sea level rise is accelerating and global temperatures are increasing. All this poses an immediate risk for Singapore, a coastal, low-lying city with about 30% of the island less than 5 meters above sea level. I'm venturing into islands off the coast of mainland Singapore to see what answers nature may hold. Our day begins as the sun's first rays illuminate the land. Hiding in plain sight on the coast of Lazarus Island are keen witnesses to the passage of time.
So this is a fossilized coral. It was alive a few thousand years ago. You can't really see right now, it just looks like a regular rock, but then if I start to scrub it, then you can start to see the coral polyps.
The team extracts a sample from the fossilized coral and takes it to the lab to get an estimate of when it was alive.
Yeah, can you see?
Oh yeah, this area is all green. Then they measure the elevation of these corals on the island managed by the Singapore Land Authority.
By comparing that to the elevations of the living one here, we'll know how much sea level actually changed over the past few thousands of years.
So when you collect enough of these data points, what are you trying to achieve?
So the overall aim is to have enough data to try and understand how sea level has changed over longer time periods. This is data that we cannot collect based on tide gauges, because back then we didn't have tide gauges installed.
This data can then be used to calibrate a model to project sea level rise, which has already gone up by 14 centimeters from pre-1970 levels. Researchers from the Nanyang Technological University are also studying mangroves for the same reason. Here on Pulau Ubin, off the northeast coast of mainland Singapore, they can zoom into sea levels several thousand years back. Using a technique called coring, they travel back in time with each centimeter into the ground to uncover its evolution into a tropical forest today.
Each 10 centimetres is approximately taking you back 100 to 500 years in Earth's history. And so when we get down to a depth of around 70 centimetres, the material is completely different. We find sandy material indicating an open bay. You go a further 50 to 100 centimetres, you find a mangrove forest. You've got a 2,000-year-old mangrove lying on top of this very, very stiff, compacted clay. So that starts to indicate that this environment here in Pulau Ubin is very, very susceptible to change.
These dramatic shifts happen with subtle temperature fluctuations.
The temperature differences are at most 1 degree C. So what do you think will happen to these environments in the 21st century? We're projecting 3 to 5 degrees C temperature change globally, amplified at the tropics.
The resilience of habitats like mangroves is front and center now as they gain prominence as nature-based solutions to fight global warming. Mangroves make up about 15% of the country's coastline, and one expert estimates that they store about 1.6 million tons of carbon dioxide throughout Singapore.
And these mangroves, as well as mitigating climate change, they also help us to adapt to it. On every tide, there's mud in the water, and all of these tangle of roots slow down the water. That helps any of the mud in the water deposit and settle out and deposit.
So it grows taller and taller.
Exactly, and it might only be a couple of millimeters a year that they can trap these sediments, but hopefully if the pace of sea level rise isn't too great, it's enough, or just enough to keep pace with it.
His team is working on understanding the conditions different mangrove species thrive in.
If you plant them at an elevation that's too low, they'll be flooded too much and they'll drown. If you plant them at an elevation that's too high, they'll get too dried out. The amount of waves that they can tolerate and all these other environmental conditions. I think if we do our homework, then we're going to reduce the risk of these nature-based solutions and get them actually working for us.
Professor Fries is part of an initiative called Restore Ubin Mangroves, made up of volunteers and academics, among others.
So we have a mangrove arboretum.
The National Park Board is working with them to restore close to 6 hectares of mangroves on the island and protect the coastline from erosion.
Here we are in the mangrove nursery, and what typically happens is that we will go out sometimes with our volunteers, right? And we collect all these mangrove seedlings. These are called propagules. We grow them out, and then after that, they can be planted out into the mangrove arboretum or into habitat enhancement projects.
They aim to complete restoration at former prawn ponds at Sungai Durian in the southeast of Pulau Ubin by 2024.
A large part of it will be to allow Mother Nature to take its course by creating the most optimum condition for mangrove plants around that area to naturally propagate and recruit and grow baby plants.
They are also looking to protect Ubin's northern coastline, such as by placing rock revetment under eroded mangroves. Soil will be laid underneath to help mangrove plants grow along the structure. National Water Agency PUB is also studying how nature can complement engineered solutions like seawalls and revetments to protect coastlines.
These kind of measures offer multiple benefits. In addition to coastal protection, they can help to enhance the biodiversity and also create utility by incorporating recreational spaces and also help in carbon sequestration.
She says it is a chance to reimagine the country's coastline. But the existential threat posed by climate change looms. Researchers say they cannot rule out sea level rise of up to 5 meters by year 2150 under a high-emission scenario paired with high-impact, low-likelihood events, such as with rapid loss of ice sheets. And the clock is ticking, with COP26 in November touted as the world's best chance to avoid the worst effects of climate change and preserve life as we know it.